Okay, this video is going to be sort of our final guide on completing the square. Now, this time I'm not going to write down a specific step-by-step method to always take because sometimes these problems can go a couple of different ways. So, I'm just going to do this through a couple of examples. Example 1. So what I've got here is y equals x squared plus 2x minus 24, and I want to put that into vertex form. Well, I know that vertex form involves some sort of completed square, so I'm going to put y equals x squared plus 2x plus some blank minus 24. Okay? So let's see. What number belongs in that blank to make a perfect square? Well, if I take my middle number here, 2, and I divide it by 2, I get 1, and then I square it, giving me 1. But I can't just add 1. Now, with a lot of you, as I've been working with you individually or in groups, I've asked you questions like, what do I have to do to get back down to the 24 or to the negative 24 that I had before? Or, what can I do to compensate for this plus 1? What we're really doing is we're subtracting another 1 off. Right, I'm allowed to add 1 with one hand, essentially, and take away 1 with the other hand. I haven't actually changed the value of my equation. Again, I've just changed the way it looks. Because, and if you were watching the last video, you should be able to see this pretty quickly, we now have y equals x plus 1 squared. That is this entire block here. This entire block here factors into x plus 1 squared. And what's left? Minus 24 combines with minus 1 to make minus 25. My vertex is negative 1, negative 25. My axis of symmetry is x equals negative 1. Let's do another one. Okay, our second example, y equals 5x squared minus 20x plus 6. Now don't let the fact that there's a 5 in front of the x squared upset you. We will be able to handle it. It won't be too terribly difficult, and in fact it is something we've sort of already been doing in this class. So here's what I'm going to do. Same as before, I'm going to sort of section this 6. I'm going to sort of section that off. I'm not really interested in that just yet. I am going to take the 5 out of the first two terms, however. So 5 times x squared, well 5x squared divided by 5 is x squared. Negative 20x divided by 5 is negative 4x, and this is where I'm going to put my plus blank. So I need to have this x squared here by itself in order to complete the square. So if there's anything hanging out there with the x squared, like that 5 that was hanging out with it, I have to factor that out, even if it makes the problem ugly, and it will sometimes. Even if it makes the problem ugly, I have to factor that 5 out, at least of those first two terms, so that I can figure out what number I need in order to make a perfect square. So, as of right now, we take this middle number, negative 4, we divide it by 2 to get negative 2, and then we square that to get positive 4. Now, normally, what we did last time is we would have subtracted 4 off of this as well. However, I want to make it very clear, we're not just subtracting 4. This 4 isn't just a 4. That 4 is 5 times 4. That 5 is still there. It's not gone anywhere. So that 4 is actually 4 times 5, which is 20. So I'm actually adding 20 with one hand, so I need to take away 20 with the other hand. So my vertex form is y equals 5 times x minus 2 squared. Again, that entire x squared minus 4x plus 4 turns into this x minus 2 squared. They are equivalent. Combine like terms, plus 6, negative 20, minus 14. My vertex is 2, negative 14. My axis of symmetry is x equals 2. And hey, I've got a 5 times vertical stretch. Our next example will be y equals 3x squared minus 6x minus 34. So once again, I'm kind of only going to look at the first two terms for the moment. I'll deal with this negative 32 a little bit later. So I'm going to factor that 3 out of the first two terms. So I get y equals 3 times x squared minus, let's see, negative 6x divided by 3 is negative 2x plus blank minus 34. So as you can see, I'm focusing on finding and completing this square first, and then I'll deal with whatever other fallout I need to deal with after that. So to find that complete square, I take this middle number, negative 2, I divide it by 2 to get negative 1, and then I square it to get positive 1. Now again, I'm not actually just adding 1, I'm actually adding 3 times 1. So to compensate for that, I'm going to subtract 3. Again, I can't just add something to an equation without compensating for it somehow. So if I'm adding 3 with one hand, I have to take away 3 with the other hand. Okay, well, the whole point of this, x squared minus 2x plus 1 is the same thing as x minus 1 squared. The 3 is still there. And negative 34 minus 3 is negative 37. So our vertex is 1, negative 37. Our axis of symmetry is x equals 1. And we have a 3 times vertical stretch. If you really want to challenge yourself, see if you can also find the y-intercept and the x-intercepts. But for now, let's move on to the next example. Example 4. 2n squared plus 5n minus 7. So looking at this problem, the first thing I notice is how much easier it would be to put this into factored form. Unfortunately, that's not what we're doing. We're putting it into vertex form, which is going to be a whole lot less fun. So again, the negative 7 we're going to kind of section off for a moment. And this is going to be 2 times n squared plus, what's 5 divided by 2? 2.5n plus blank minus 7. Remember how I said that when you are completing the square and there's a number in front of the n squared or the x squared, you got to factor that number out even when it hurts. And in this case, it definitely hurts. Now I've got my calculator on me, so I know that 2.5 divided by 2 and then squared is 1.5625. I also know that I'm subtracting not 1.5625, but 2 times 1.5625. So I'm actually subtracting off 3.125. Again, I want to make it as clear as I can that this number, which I added with one hand, and this number, which I subtracted with the other hand, are the same, and that's why I'm allowed to do it. Because I added 3.125 in here, I had to subtract 3.125 on the outside. Okay. Finally, last step, I promise, 2 times n plus, what is 2.5 over 2, actually? 2.5 divided by 2 is 1.25 squared minus 10.125. So our vertex is negative 1.25 comma negative 10.125. Our axis of symmetry is x equals negative 1.25, and we have a 2 times vertical stretch. So that is a basic primer on how to complete the square in basically any situation. Now, this is one of those things that has a lot of steps to it, so I expect it to take a lot of practice. You've got about a week left between the time I drop this video and the time the exam happens, so get practicing.